So I think we can start. Um, all right. So hello, everyone. Thank you for attending this event, and thank you to the live audience here at Purdue University. And thank you to the organizers for making this wonderful event possible. So my name is Igor Nikitin. I'm co-founder and CEO of Nice Technologies. My background is actuary and software engineer, and I have about 15 years of experience. So this presentation will focus on feasibility analysis of replacing actuarial modeling with AI. And we will try to approach it from a more quantitative approach to get some concrete numbers and look at some concrete issues and try to see whether those are feasibly surmountable. And if yes, then when. Now, this analysis, we will use a specific use case, but I think the methodology being used can be applied quite broadly to a wide range of different applications of AI. So most of the people in this presentation use actual modeling software, and whether it's in-house or third party. And I have attended quite a few conferences recently, and there was one question that came up several times from senior management of insurance companies. And the question is, will actuarial modeling software get replaced by AI? In other words, would we be able to ask a platform like ChatGPT, just plug in our data and get financial reports out of it without having to manually do all of the formulas and runs and clouds, etc. So in this presentation, we will consider that question. Now, we will attempt to answer this question in a very quantitative way, because obviously we can speculate a lot on whether it will or whether it won't. So here we try to put some numbers together and look at it in a very quantitative lens and say, okay, how much do things cost? What are the restrictions, etc. And the first thing would be to do the analysis of what do we know today, what we don't know today, and what useful estimates can we make. So what do we know? We know complexity of a problem, right? So for this particular problem, we will take a use case of modeling, and we will describe what exactly our model run is, how many times per year are we running that, and kind of calculate the total cost that would basically cost today. We know how much workload using AI will solve. We know what AI costs today, as well as we know some of the parameters around its context, size, and other limitations. We also know regulatory and professional environment, and we can draw some conclusions out of that as well. Now, what do we not know today? The biggest thing we don't know is scaling of the AI. So the models have undeniably become better over the last 3 years since they were released. But it would be interesting to see. It is hard to predict how quickly will they become even better than today. And if they do become better than today, then how much better? The other thing we don't know is the scaling of compute power. And the biggest elephant in the room there would be the quantum compute. It is eventually going to be production ready, but as of right now, we don't have it in our laptops yet. Um, Now, what useful estimates can we make, right? We can, first of all, do the actuary thing and set some assumptions, right? So we can assume that AI is perfect. And it's not realistic, but it is useful for the purpose of this case study. We will assume that it will provide you perfect answer to your problem. Um, and based on that, we can actually estimate some costs, right? We know regulatory requirements, so we can consider how could current requirements change or not change in the context of AI. We can do and we can do estimates of cost to overcome some of the limitations that we know of, and we can consider what would it take to overcome some of those limitations. Um, so on to our case study. So for our case study, we considered a model that projects expected cash flows for 1 million pensioners. And on this slide, I'm kind of describing what that roughly looks like. So this model takes population of pensioners and description of their pension benefits. It estimates how long will the pensioner live. It calculates pensioner benefits, cost of living adjustments, spousal benefits, and other plan-specific requirements. And it produces a stream of monthly expected payments. We can then calculate how many times per year a business would run this. And for this analysis, we're going to assume that we have 4 valuation cycles with a dozen or so sensitivities in each one of those. And then we will add some runs for margin for error and kind of reruns and that kind of thing. And we will say, okay, this business is, let's say, something like PRT. So there is also active pricing runs. Altogether, we would estimate that there's about 1,000 runs of this model per year that is happening. So next, we will take that knowledge and we will calculate how much will it cost in today's setup using traditional actuarial models. So we will ignore license and consulting costs to keep things simple, since we will later see that these are actually irrelevant. So this kind of model will easily run on a high-end AWS machine in under an hour, and high-end AWS machine for an hour costs about $10. We will also assume that maintenance and development of this model requires full-time employment of 2 skilled actuaries, and we assume that each of them has a salary of $250,000 per year. Maybe they live in like New York or California or something. So with that, we can add all of these numbers together and get a total annual cost of about $500,000 per year. All right, great. Now let's do some numbers for the AI. So we will use ChatGPT for this analysis, and we will assume that it will produce perfect numbers, right? That results it produces are just exactly what it should be, and it doesn't make any mistakes. So we can feed population and parameter files into ChatGPT and get a file with resultant cash flows that we want, right? That would be a definition of kind of AI does it, and then I don't have to have 2 full-time employed actuaries kind of working on modeling of this, right? So ChatGPT charges for input and output tokens. Now, each token is roughly a word, but it is worth noting that floating point numbers are typically represented as 3 tokens. And here's a summary of the pricing of ChatGPT. Now, this is from November of last year. So, but on the next slide, I'll see we will see where that went from since then to today. So back then, right, we will do this analysis for the best model available and the cheapest model available, just to get us an idea of what's the range of the cost that's going to be there. So cost is per million input tokens and per million of output tokens, right? For best model, it's $1.25 and $5, and for cheapest, it's 7.5 cents and 30 cents. So let's calculate the number of tokens that we will need for our use case model to run and produce our results. Before we do that, I very quickly pulled the ChatGPT pricing as of yesterday, and I compared to where the prices are relative to a year ago. And what I found is that overall they went up very substantially. So on there is a best model that got added, and that one is 12 times more expensive than what we had in our analysis. And I'm not sure how much better it is, but since we assume that we already use the best model, we will actually use the numbers that we had from last year, and then we can just adjust for this later. And then costs of the cheapest model and kind of reasonably priced model on the input side, it remains the same or became slightly less. On the output side, it became either twice more expensive or 30% more expensive. Now, it's worth noting that OpenAI lost about $11 billion in third quarter of 2025. And to me, that says that their prices would have to go up for them to make money. Which means that these price increases they're probably going to continue. And in fact, I think that this pro model here might be an attempt of kind of market testing and seeing whether anybody would actually pay this or not, because it is indeed very impressive how expensive this is. So with that, back to our case study. So our case study model has 30 fields per policy, right? And we're trying to estimate the number of input tokens that we would need to put into ChatGPT to do our cash flow calculations. So let's say there are 30 fields per policy. So that's and 1 million policies in this case study, right? So that would be 120 million population input tokens, right? And I'm showing the math here. It's pretty straightforward. You just kind of multiply the fields by tokens, add the comma separators, and number of policies. And then for the assumptions, we say that we have about 100 megabytes of assumptions. A lot of that is going to be things like mortality improvement tables. This is actually can be a lot higher for the pension use cases, but let's say 100 megabytes is a reasonable estimate. So 100 megabytes, we can convert that into tokens, and that's going to be 25 million assumption input tokens, right? So altogether, 145 million input tokens, and multiplying it by the price of the input tokens, we get $181 on the best model and about $11 on the cheapest model. Next, we're going to calculate the cost of the output tokens. So what we will do, we will say, okay, let's say I just need a summary of 10 monthly vectors for 50 years. So that would be 25,000 tokens and that's just the size of our output file, right? But for a lot of our use cases, we actually need seriatim data. So what if we need present value of benefits as one number per policy, right? That becomes 3 million tokens. And then if we need seriatim cash flows for each policy, that would be 2.4 billion tokens. So as you can see, getting seriatim results requires a whole lot more tokens to be even outputted. So next, we take the number of tokens that we've calculated and we multiply it by the cost of the output tokens. And we get this table here. So what we learn is that for the summary output of just 10 monthly vectors for all of these policies, right? Our cost will be between 12 cents and a little under a cent. Okay, that's very reasonable. But as we go down the amount of outputs that we want, so one present value of benefits per policy is already $45, and one monthly vector for each policy is between 12,000 and $750, depending on whether you use cheapest model or the best model. So next thing to consider is the cost of intermediate calculations. So obviously, going straight from input of the census of the pension plan to the cash flows for each individual will require some intermediate calculations. It is not something that can be estimated accurately just by looking at the inputs. So LLMs work best with chain of thought reasoning, and that requires some tokens for intermediate calculations that are kept tracked as the model does thinking, right? Um, so we know that each vector of these calculations will cost between 720 and $12,000 doing it for each policy, right? So then we say, okay, if we have 50 vectors of intermediate calculations for each policy, that would cost us anywhere between 600,000 and 36,000, depending on best model versus cheapest model. And if we doing something like deferreds or something like reserve projections, then the number of vectors will be substantially higher. And we would say, okay, let's assume that it's about 1,000 vectors per policy. And at that point, our best model would cost $12 million in just the output token cost. And that is starting to get very, very pricey. Now, the cheapest model is not too far behind. That's still $720,000. So, and this is just one run of this 1 million policy block, assuming that it does these intermediate calculations, right? Um, so, so let's add up all of the AI model run costs and get a price for a single model run and price per year, assuming we manage to replace both actuaries who used to do this with traditional models. So if we add all of this up, right? So total cost per model run with 1 million policies that has 50 intermediate vector calculations per policy is on a best model, 600,000, and on the cheapest model, 36,000. And obviously with more intermediate calculations, those numbers become 12 million and 700,000 respectively. So now let's recall from the beginning of our case study that we will run this model about 1,000 times per year. And if we do this very simple math here, we discover that it cost us between $36 million and $12 billion. So that is definitely not economic. I would keep the two actuaries and $10 per run cost. So what we conclude is that if we have an approach that relies purely on kind of ChatGPT type of calculation with current LLMs and current pricing and current technology, then replacement of traditional models with ChatGPT models, it simply doesn't make economic sense because we would go from about 500,000 per year of that we pay for traditional modeling to anywhere between 36 million and 12 billion for AI modeling. So we need far better algorithms and far cheaper compute to bring this equation to some sort of economic feasibility. Now, the next thing to consider is regulatory considerations, right? So From the regulatory standpoint, if we need traditional models to validate AI models, then why do we need AI models given their high operating expenses, right? Um, so we know right now that AI cannot be trusted as is because it tends to hallucinate and it's difficult to explain the results, especially if you feed large volumes of data into it. So at some point, AI might become reliable enough to where it can be trusted, similar to an actuary, or there would need to be some sort of regulatory change that allows AI to sign off on results as opposed to humans. But that is quite far in the future and not something that will happen. Not something that I think will happen in a foreseeable future. Um, so to make this AI approach feasible from regulatory perspective, we basically need a societal and regulatory shift that will come only after AI models become extremely reliable and can rival humans on accuracy and care for things that us actuaries are pretty good at. The next hurdle that we assumed is not a problem, but it is indeed a huge problem, is the context size. So, context size is the amount of data that a model can hold in its memory at one time, right? So, if you put more data into the current LLMs than their context size, then the data will be truncated. And basically, the model will no longer know about part of this data. So, current generation of LLMs, their context sizes are around 128,000 tokens. And I checked that this actually has not changed since last year. Now, this is for ChatGPT. There are some models that have bigger context size windows, but they're several times bigger. They're not okay, so maybe not several times. Basically, like 3 to 5 megabytes is the cutting edge today. So that would be roughly five. So roughly 15 times better, right? Um, Now, the 128 kilobyte or 128,000 tokens in ChatGPT, this is about 43,000 floating point numbers. And knowing the structure of actuarial assumptions, mortality improvement tables alone can be larger than that. So if we do like 81 ages times 20 improvement calendar years, times two genders, times four income bands, times three occupation types, that gets us basically to the limit of the context window in the chat GPT. So that means that evaluating our million policies in one shot will be impossible. And for that, we would need to slice up our in-force and evaluate it in blocks of 1 to 10 policies at a time with the current model limitations. So to handle the entire run, we would need 2 to 5 billion tokens or 15 to 20,000 times larger context. And in current models, doubling context size quadruples complexity. And that means that our desired model would need to be about 225 million times more complex and likely equally many times more costly to run. So I checked on the context size, and since last year, it did not increase for ChatGPT. So it is a bit of a it's a bit of a plateau in terms of scale in it. And the real breakthrough will probably be possible only when we get drastically better technology. So something like quantum compute, basically. Um, but for now, that is an interesting thing to consider. Now, there are also better algorithms that could emerge and supplement the traditional programming and actual reasoning to um, to make this more feasible, right? So an example of those would be something like Google DeepMind, and it's famous for being able to solve mathematics Olympiad problems. But if you read about that model, you will discover that it does iterative learning basically in a process of answering the question. That means that its compute costs are far higher than the LLMs that we have today. And hence, even if it was capable generating the of generating the accurate output, it would likely cost a lot more than even the estimates that we've had so far. So it would be better, but still not perfect and still very, very expensive. Now, the other direction that this could go is having models that would generate your traditional models, if you will. So having an LLM that will generate, let's say, Python code and have that Python code execute the processing of the data um, and deliver it that way. The challenges there is if you estimate how big that Python model would need to be to generate the output, that would be several megabytes. And several megabytes of Python, first of all, it's a whole lot of Python. To checking that and making sure that it does what we think it does would be a challenge because um, that's a lot of data if that data is actually code. Um, and hence, and one other observation there is if it is several megabytes, that's bigger than a lot of the current LLMs, which means that to even generate that Python code, you would probably need to slice the problem into several pieces. And then you run into an issue of how do I make a coherent piece of code that operates the way I want, generated by an LLM. Um, and that would be a very big challenge to overcome and to make it reliable, auditable, and have people who sign off on these results and regulators be comfortable with how that is produced. So with that, I would like to turn over to audience for questions. Okay, so I see chat. One second.
Igor, I have a
All right.
question.
Yeah.
Based on how things are developing, do you see potentially a timeline? Like, would you say, there's obviously so many hurdles for this type of AI to replace this type of work. Do you see like any sort of time horizon where the answer could be yes?
So one, we would need drastically better compute
Mhm.
and or drastically better models. Frankly, due to the nature of the LLM models, I don't know that that is ever going to be the answer in the context of what we do. One other thing to consider is they're looking at it once again from cost perspective, right? And any kind of AI model, regardless of whether it's LLM or not, it has some overhead comparing to a model that is using traditional programming, right? Because the model using traditional programmer, it basically tells computers this is exactly what you need to do and nothing else, right?
Hmm.
Versus AI model would have to have substantial amount of overhead to be able to calculate same things and come up with a correct answer, right? So it will never be as efficient. Now, the question is, you have basically salaries of your staff versus the cost per run of the model. And those two need to somehow align on the kind of total modeling cost for the year, right? So when will AI be able to generate your output at the cost comparable to salary of two actuaries, let's say? I'm not sure we'll ever get to that point just because it would. So traditional model run costs like $10, right? Actuaries cost 500,000. So 500,000 divided by 10, so it's 50,000. And that's just one run. Oh, yeah. So 1,000 runs of traditional model is 10 times 1,000. So 10,000. You spend 10,000 on model runs, 500,000 on salaries of actuaries. So if so basically the difference between your traditional cost of model and your AI model must be 50 times or less to make this equation work. Um, I don't foresee a future where that overhead is going to be just 50 times. That is very tough bar, I
It's
think, to reach.
almost it's almost as if the path we're on never gets there, and there's going to have to be a new path, a new development, like a new methodology, effectively. Still in the AI space, but a new approach, not an LLM. Actually, we have a question that you might want to look at there, the last one in the chat.
Um, so, dear Igor, I listened and took in. Oops, 1 second. But I don't think at this stage LLM is what you should consider. The cost is astronomical. And no, I can promise you the best compute, aka quantum compute, will still not give you the desired answers. How about investigating from core actuarial principles with the benefit of supercomputing that gives the best approximation of what you want as output? Yeah, so this was kind of not in scope of this exercise, right? Because we kind of tried to estimate just LLMs and answer this question for LLMs specifically. So I think investigating kind of from core principles and benefits of supercomputing, that's a kind of separate talk and separate research. Would a more practical use of AI in actuarial modeling be to have an AI agent manipulate model inputs based on an actuary's high-level instructions and run the traditional model in software as we currently would today? Yeah, I would agree that that is the most practical approach today. You can absolutely have AI assist with model development in the context of a traditional model. And in fact, tools like GitHub Copilot, for example, have proven that that is indeed a very feasible and economical and frankly effective path of doing it. But the question that I was originally answering was, will traditional models just go away altogether and be replaced by AI? And that's what inspired this research.
Well, it's quite interesting. Oh, yeah, here we got another one.
Amazon cloud revenue profits are incredibly high right now. Due to cost of raw compute, wouldn't we see cost of AI have to increase at some point? Cost of raw compute. Yes. So I do believe that cost of AI will increase. One, because it needs to become profitable. Because it's not sustainable to lose billions of dollars per quarter, and something must change. You cannot do that indefinitely. Uh, to a year ago, there was an argument that, like, well, the cost of AI will eventually come down. Looking at it now, we confirm that they did not come down. In fact, they went up, and they went up substantially. Um, One challenge with AI is I think it's a little bit of a business model approach, is kind of get everybody to like it, and then increase the cost later. Um, and with this analysis, it's not only in the context of modeling, you can actually apply it to a lot of other types of applications. So, for example, let's say you have some data and you want to get some insights out of that data, and you build some prototype and you say, okay, great, out of my little prototype, it seems to give me the right answer. I would encourage you to kind of sit down and think through like input tokens, output tokens, and how much would it cost if you feed production type data and multiply it by the number of production type runs, and make sure that number does not come out to be astronomical, because then your IT will quickly say no, and so will your business team.
Yeah, the AI space kind of reminds me a bit of like the Lyft and Uber kind of thing where they started for many, many years just losing money because they're trying to get everybody hooked, change people's habits to use this. It's so cheap, and then eventually they have to make a profit, so they raise the prices. Yeah. Okay. Well, do we have any more questions?
So I see one comment: AI pricing is at most 20% where it should be. Way oversupplied. I'm getting shadows throttled all the time. So I didn't know that it's estimated to be at about 20% of where it needs to be. So that's an interesting way to think about it. Um, right. So I'm looking at the first comment. So, Igor, how can ChatGPT others get access to corporate data? Profit other models are much too complex. But looking forward to presentation. So there's a comment from Robert. The agent would have to be installed on premise or on network and not have access to external data other than specific in-force projection assumptions, etc. Right. So for something like this, it would need to be very secure. But before even considering security, it just worthwhile to consider kind of the cost and whether it's feasible or not. Um, there are some conversations that I had with business leaders on, can we use AI for analysis of like financial results and large volume of financial data. It's interesting to think through the kind of volume of data that is being considered there, and whether it would be more cost effective to use AI for that or to hire a data scientist. Because I would argue that quite often a data scientist would be both cheaper and more insightful than AI. Any other questions?
Okay. Well, thank you very much for the great presentation, insightful conversation, Igor.
All right.
And
Thank you, everyone.
thanks everybody
Have a
for
good
attending.
afternoon.